Flip a switch and you'd expect the current to appear instantly. Put a coil in the circuit and it doesn't. It ramps up on its own schedule. And when you switch it off, the coil fights you with a jolt of voltage. One number sets all of that timing. The time constant, tau. And it's just L divided by R. Last time, we watched a capacitor resist a change in voltage. An inductor is its mirror image. It resists a change in current. Push current into a coil, and its magnetic field pushes back with a voltage that opposes the change. That's Lenz's law. So the current can't jump. It has to climb, and the coil sets the pace. Here's a simple RL circuit. A source, a resistor, and a coil. Close the switch. The current doesn't slam to full. It rises smoothly, curving up toward its final value, which is just Ohm's law. V over R. The coil is what delays it. How long that delay lasts is the whole story, and it all comes down to tau. The time constant, tau, equals L divided by R. Henries divided by ohms gives you seconds. In 1 tau, the current climbs to 63% of its final value. Not all the way, 63%. Each tau after that covers 63% of the gap that's left. After about 5 taus, it's essentially full on. And notice something. A bigger coil means a slower ramp, but a bigger resistor makes it faster. That's the opposite of the RC circuit. Let's put numbers on it. A 2 Henry coil, a 2 ohms resistor on 12 volts. Tau equals L over R. 2 Henries divided by 2 ohms is 1 second. The final current is Ohm's law. 12 volts over 2 ohms equals 6 amps. So after 1 second, 1 tau, the current is at 63% of 6 amps, about 3.8 amps. After 5 seconds, 5 taus, it's essentially the full 6 amps. The coil is now fully energized. Now, open the switch. The coil refuses to let its current stop instantly. To keep it flowing, the coil makes a huge voltage spike, sometimes hundreds of volts. That's what arcs across switch contacts and can destroy electronics. That stored energy dies away on the same clock, dropping 63% each tau, so it's down to 37% after just 1. That's why relays and solenoids get a flyback diode across them, a safe path for that collapsing current to fade away. So remember, tau equals L over R. Current in a coil rises and falls on that clock, 63% per tau, and a coil always fights a sudden change. Next time, another piece of the puzzle. Grab a pencil, and I'll see you there.